Welcome back, everyone, to another exciting episode of Dave Does Math from Home. Today we are talking. Oh, that's wrong. Sorry. Today we are talking about section 1.2b, which is different from 1.2a. The book put them in the same section. The book chose to lump these two categories both as section 1.2, but I think they deserve to be separated. There should be some distance between these two. 1.2b is about rational equations. So when we did 1.2a, we only looked at the linear equations, which is its own entire set of things that we have to deal with. Now we're going to look at rational equations. And before we get into what a rational equation is, I want to just do a quick review of some of the things we did in 1.2a. One of the kinds of problems we looked at in 1.2a was the problems of like 1/2 x minus 3 equals 1/3 x plus 4, something like this. This is a linear equation because it has x's to the first power, it has coefficients, the coefficients happen to be fractions, and it's got constants, and that's all fine. That makes this thing a linear equation. And in section 1.2a, we said that when this happens, the correct maneuver is to get rid of all the fractions. So if there's a 2 here, we're going to multiply everything by 2, and that clears that. That'll just leave us with x minus 6 equals 2/3 x plus 8. And then we still have fractions after that, so we're going to clear the fractions even more. We're going to multiply everything by 3. So this will leave us with 3x minus 18 equals 2x plus 24. This was our plan. Once you clear all the fractions, the thing that's left should just be a linear equation, which is great because we can solve linear equations very easily. We'll just move the 2x over here, move the 18 over here, and we'll get x equals 42. Nice. So that's how we handled linear equations with fractions in them in section 1.2a. Rational equations are a little bit different, but they follow a lot of the same principles. A rational equation might look something like 3 over x equals 11 over 5x plus 4. The big difference here is that in this equation we had fractions, but they were just coefficients. Our x's were very mundane x's. They're just, this is an x to the 1 power. There's no surprises here, nothing weird is happening. Here our x's are in the denominator. The coefficient is 3 and the x is tucked underneath it. The x is part of the fraction. It's not like there's a fractional coefficient and x is normal. The x is in the denominator. This, Suna, could you please be quiet? Suna. My cat is really unhappy that she can't get in here. So, when you encounter this kind of a problem where there are x's in the denominators, the basic plan is going to sort of follow this. The basic plan here is get rid of all the denominators. Make the fractions go away by multiplying by things until everything is out of denominators, everything is numerators. You can multiply both sides of this equation by anything you want, and eventually that should clear out all the fractions. That plan is the same. The big difference is now when we multiply by these denominators, we're going to be multiplying by x and 5x. And we're going to have to cancel these pieces with x's in them. Instead of just canceling the 2 and the 1/2, we'll be canceling x's and 1 over x's and stuff like that. So there's a little bit more algebra involved there. The other thing we have to look out for is domain restrictions, just like what happened when we did section P6 and we started doing rational expressions. We had to be very cautious of these domain restrictions. There are certain x values that these things can't be. Like in this one, I think it should be pretty clear that x can't be 0. So the thing we have to be really careful about is if we solve this equation and the solution is like, I don't know, x equals 10 or something, great, that's fine. That's not a problem. We can deal with x equals 10. If we solve this equation and it turns out that the solution is x equals 0, then we have a big problem because x can't be 0. So if your solution set for your x's after you've cleared out all the fractions and you get your answers, if your solution set matches your domain restrictions, then you don't really have a solution set. We'll talk about what that looks like in a second. I want to start with actually solving this guy. As usual, my plan is just going to be pick a denominator and multiply things by it until the denominators are gone. X times 3 over x should just give me 3. X times this should give me 11/5 plus 4x. Remember that you have to multiply, just like when we multiplied this by 2, it hit everything. Same is true for this. We have to multiply this x by all of the pieces. One of the most common mistakes I see students make on problems like this is multiplying the x here and here, but forgetting to multiply the x here. It has to hit everything. I still have denominators, so I want to multiply everything by more denominators until the denominators are gone. So this will be 15 equals 11 plus 20x. So I'll subtract 11 from both sides, and I'll get 4 equals 20x, and then I'll divide by 20. And I should get x equals 1/5. So now we have to check. 1/5 is not our domain restriction. So we're all set, we're good. You could also check this answer by plugging it in to the original equation. This would give you 3 over 1/5 is 15 equals 11 over 1. It's just 11 plus 4. And yeah, that works out. 15 is 11 plus 4. So once you finish this process of multiplying everything by all the denominators, you should end up with a linear equation. Just like here, we multiplied by our denominators, we've got a linear equation, and we know how to solve linear equations. Same thing will happen with these. You just have to multiply by the x's as part of that. So that's the introduction to these problems. I'm going to erase all this and do another one that is slightly more exciting. Okay, what is the next one I want to do here? Let's look at 1 over x minus 2 plus 2 equals 9 over x minus 2. So for this one, the plan is still the same. We're going to multiply by, I erased the title. I usually don't erase the title. That's fine. I'll write it up when I'm done with this problem. The plan is always still multiply by denominators. In this case, that means we have to multiply everything by this quantity, x minus 2. So when I multiply this term by x minus 2, I'm just going to get a 1. Because these things, oh no, I skipped a step. X can't equal 2. Got to make sure that's in there before we clear out these denominators. I multiply x minus 2 times this piece, 1 over x minus 2. The x minus 2's cancel and I get 1. This will be 2 times the quantity x minus 2 will give me 2x minus 4 when I distribute that. These guys cancel and just give me 9. So I'm going to subtract 1. I'm going to add 4. So this should give me 2x equals 8 plus 4 is 12. So I think that'll end up with giving me x equals 6. So now we're going to do both of our checks. First, does it match our domain restriction? It does not, so we're safe there. Does it actually give us the number we want? 9 divided by 4 is 2 1/4. And 2 plus 1/4 is also 2 1/4. Okay, so this passes all of our checks. It is what we wanted. I'm going to erase this so I can rewrite the title of this section. Back up. And then I'll do another example. We're still doing section 1.2b, rational equations. So next, let's look at 5 over x plus 8 minus 1 over x minus 8 equals 2x over x squared minus 64. This is where things start to get pretty exciting for us, because we have to be factoring things now. So first thing I'm going to do is factor all the denominators so that I know all the different pieces I'm working with. This denominator is already factored. This denominator is already factored. This denominator factors into x plus 8 and x minus 8. So that's nice. Now that I have all of the pieces laid out, I'm going to do my domain restrictions. X can't be 8 or negative 8. This one has 2 domain restrictions. So I have my domain restrictions, I have everything factored. I'm going to start multiplying by denominators until the denominators all go away. I'm going to start with x plus 8. X plus 8. On this side, cancels here. For this piece, it cancels and leaves me with a 5. For this piece, it'll be minus 1 times x plus 8 over x minus 8. These pieces don't cancel. And then rewriting this, I have 2x over x minus 8. So we still have denominators in here, so I'm going to multiply by my denominators again. Multiply everything by x minus 8. Here, again, things cancel. For these pieces, they'll cancel. This will give me a 5 times x minus 8. Minus, here they cancel. 1 times x plus 8 equals 2x. So, as promised, eventually we find ourselves looking at a linear equation. It didn't start linear. It started as a rational equation with quadratic denominators. But at the end of the day, we get something that's linear. And we know what to do with linear equations. We distribute. I'm going to come up over here. We distribute 5x minus 40 minus x minus 8 equals 2x. We combine like terms. 4x minus 48 equals 2x. We rearrange things. So I'll put the 48 over here, and I'll subtract 2x from both sides. So I have 2x equals 48, and then we divide to get x equals 24. From, where's my finger? There we go. From here, we still have to do our checks. We should check that our answer doesn't match our domain restrictions. And it doesn't. We're all in the clear there. And we should check that it actually solves this. So this will be 5 over 32. Ooh, that's rough. Minus 1 over, oh, 16 is not that bad. Okay. Oh, but this denominator is going to be 24 squared minus 64. Okay. I'm not going to check this one by hand. Use a calculator. Check to make sure that both of these sides match. I don't know what 24 squared is off the top of my head. It's probably like 570 6 maybe, I don't know. If you want to check it, use the internet. I'll trust that it's correct, because I want to see if I can finish this whole section in one video. We're at 15 minutes so far. So I think I can do this last problem in 5 minutes and then be done. Okay, the last problem is 1 over x minus 4 minus 5 over x plus 2 equals 6 over x squared minus 2x excuse me, minus 8. So once again, great first strategy here is going to be to factor this so that you understand all of the different pieces that you're working with. And usually for these problems, if you have to factor something, the two factors are these things. That's going to happen almost every time. So 1 over x minus 4 minus 5 over x plus 2 equals, the numbers that multiply to -8 and add to -2 are, in fact, -4 and +2. So hopefully that is not a surprise to anyone, that these things sort of end up matching. So we got it factored. We have all of the different pieces laid out in front of us. We can very easily hit our domain restrictions right now before we do anything further. And then we can start clearing out denominators. We multiply by x minus 4 on both sides. Here it cancels with this, and then it cancels here and leaves us with just 1 minus 5 times x minus 4 over x plus 2 equals 6 over x plus 2. We still have denominators, so we'll clear those out as well. X plus 2, x plus 2. So here we get 1 times x plus 2 equals, sorry, not equals, minus. Here they cancel and just give us 5 times x minus 4 equals, cancel, cancel, equals 6. So we have reached our linear equation stage of things, and we can just start solving this like we would any other linear equation. I distribute, I get x plus 2 minus 5x plus 20 equals 6. So this is -4x plus 22 equals 6. I'll subtract 22 from both sides. I get -4x equals -16, which means that x is 4. So you take your answer, x equals 4, and you plug it into MyMathLab, and MyMathLab says, you're wrong. And you're like, what just happened? X is clearly 4. I did all the steps right. What went wrong? And then you remember, I solve it like it's a linear equation from here, but it's not actually a linear equation. It's a rational equation, and those have domain restrictions. And x equals 4 is no good. So you cross this out, you draw a little frowny face because it's no good, and then the answer you put into MyMathLab is no solution. Or I think MyMathLab has like MyMathLab uses like this symbol for the empty set. The solution set is the empty set, which is just a really unnecessarily verbose way of saying that there's no solution. This is the empty set. I don't know why this book loves set theory so much, but it's really not necessary. The last thing that I need to talk to you about, for this problem anyway, is that this section, we worked on this section before, section 1.2. We've already done a bunch of homework problems from this section when we did 1.2a. And in that section, this section was very, very concerned about the 3 possibilities of answers. You either get one answer, like what we did in the last couple problems we did, you get no answers, which is what happens here when the answer you come up with is some sort of domain restriction thing. Or the third option that we had when we were doing 1.2a was infinitely many solutions. Any value of x solves that. And for that, I want to go back to sort of the start of this problem really quickly. I'm not going to do a completely different problem. I just want to change this problem around a little bit because I think I can make this one work out like that. I think we need to change this into a 4x. Now we might need another piece here. Negative 4x plus 22 maybe. We'll see if this works. Plan is still the same. Factor the bottom. We still know it factors into x minus 4 times x plus 2. I'm going to skip a step because we're already at 21 minutes and I want to do this real fast. I'm going to multiply by both denominators at once. So both of them cancel on this side. And when I multiply by x minus 4 and x plus 2 over here, the minus 4s are going to cancel in this first place and leave me with just x plus 2. And the plus 2s are going to cancel on this piece and leave me with negative 5 times x is negative 5x. Negative 5 times negative 4 is positive 20. And on this side we have negative 4x plus 22. So we can combine these like terms a little bit. This will give us negative 4x. That will give us plus 22 equals negative 4x plus 22. This is the kind of situation you're looking for to get into a x is all real numbers. This is infinitely many solutions. It doesn't matter what x, I guess not all real numbers, because it still can't be 4 and negative 2. But all real numbers except 4 and negative 2 are solutions to this equation. So that's rational equations. We went a little past 20 minutes, which I don't like to do, but we didn't go far enough past 20 minutes that I feel like this should have been 2 videos. So good work. Next up is 1.6.